Hi, everyone. In this session, we're going to talk about Amazon Textract and machine learning for understanding documents at scale. I'm John Turo. I'm part of our product management team. I'm responsible for Amazon Textract and Amazon Recognition. So let's get started. We're going to talk about what is Textract, why is it important, what is it for, who is it for. We're going to talk about what we've been working on in the few months since we launched Textract to be generally available earlier in the year. We'll go under the hood to talk about some of the deeper technical questions that customers encounter when they start to move from testing into development into production. And then you're going to hear from a real live customer, Intuit, who has spent lots of time with Textract and has some really cool results to share. So let's start at the highest level. This is what we at AWS call our machine learning stack, and it has 3 layers. At the lowest level, frameworks and infrastructure, where we push the boundaries of what is possible with machine learning by investing in new machine learning frameworks, in new types of silicon, new engines to run all this compute. At the next layer is our machine learning services platform. This is SageMaker, and its services, you've seen a lot of exciting announcements from us this week. With the machine learning services layer of our stack, scientists can train and execute models and annotate their data more effectively. That's the second layer. And the third layer, AI services, are off-the-shelf components that developers and scientists can use without having to train and create their own models. And you are here today. We're going to talk about vision services specifically that include Amazon Recognition and include Amazon Textract. Now, Amazon Textract is different from traditional document understanding services because it reads documents as a person does. And in order to talk about what that means, let's look at 3 important documents. You can think about a mortgage loan application, which carries huge amounts of equity for people to buy homes, healthcare insurance claims, voter registration forms. Even in 2019, almost 2020, tons of important and valuable data is still locked in paper and paper-like documents. And this applies across lots of industries, and especially finance and healthcare and public sector. And when you try to unlock that information from the documents, you run into a few major problems again and again. The information has relationships within the page. It's not just words. And the information is expressed in different data types, where there's a checkbox or a, would you call that a radio box on a paper? Different types of forms that express similar information may look totally different. The design is universally terrible. And by the way, when the information is captured, it gets distorted. So you don't get a clean copy of the document. And that means that the traditional ways of getting these data out of the page are broken. There are trade-offs. You can use what's called optical character recognition, which has been around for 30 years, some versions of it even longer than that. But it costs money and it costs time. And for the types of documents that you want, it's going to give you this flat bag of words. You can do manual processing. You'd have human beings read it. But hang on, that's even slower. And that's even more expensive. And it turns out humans make mistakes too. And somewhere in between these 2 techniques is an extension that has come into vogue, where you can create templates on top of your documents, have human beings validate those and pull out the words in them. But it's brittle. And it only works for one specific document type that you've configured. And you have to do that again and again and again. And it doesn't scale. And it ultimately leaves too much valuable information locked in your documents. So Amazon TextRact is different. We're going to read these pages with machine learning. We're going to treat it as a computer vision problem. And we're going to pull out three types of information from the pages that you process. The first is text, with very high accuracy. The second is tables, which are defined as content with rigid rows and columns. And the third is forms, which are defined as keys and value pairs floating around the page in no particular organization. So to illustrate this, let's look at a document. Here's a form type that is popular in healthcare insurance for insurance claims. And you can see there's lots of information on there. You can imagine it takes a while for a human reader to really parse this thing. And we can break it apart. There's text, which explains what this document is for. What's the purpose of it? How is it meant to be handled? What are the cases under which it's been filled out? There are tables, which express information in rigid rows and columns. And there are even forms, keys and values scattered around the page in no particular logic. So with TextRact, again, text and tables and forms in one consistent set of APIs with high accuracy and high speed that you can retrieve from your documents. And it's Amazon. So let's talk about this in terms of customers. Here's a customer called FileVine, which provides document discovery services for legal customers. And FileVine's document extraction is now powered by TextRact. They like that it's fast and accurate and scalable and helps the very demanding requirements of what legal customers need from the documents as they search them. As I said, TextRact is maybe some 30 weeks old since we've been generally available, and we're thrilled and we're humbled at the set of customers who are building functionality on top of this service. And it's in almost every industry, but we certainly do see patterns in finance, in healthcare, in public sector. You're going to hear from Intuit later today. We also see quite a vibrant partner ecosystem developing. Applications getting built on top of TextRact to offer value-added functionality. Solution integrators who are working with TextRact to help enterprises apply to their business problems. And as a customer, you can think about, well, hey, which of these partners can help me solve my own business problem more quickly? And as a partner, you can think about, well, gosh, how can I help my own mutual customers with Amazon really fast and take advantage of Amazon's investments? So lots of traction there. With TextRact, you're getting a line, not a dot. We're improving continuously over time. The basic idea is that you're going to be able to extract text and structured data quickly without templates and without configuration. You're going to reduce how much manual effort you have to apply in order to get those results from your documents and unlock the value from those papers. You're going to do this all with lower cost. And you don't need any machine learning experience. It's an API that you can access off the shelf because we're sitting at that third layer of the cake. So that's TextRact. Let me tell you what's new, what we've been working on in the kitchen in the past 30 weeks and longer. As I mentioned, 3 key features to TextRact. There's text, and there's tables, and there's forms. I want to spend a little bit of time on updates to our tables model, which we're pretty excited about. And I'll do that with a game. It's not a very fun game, but you can see a document here with an embedded table. And let's think about how many rows and how many columns you see. And it's a little tricky. There are some merged cells you can see at the very top. And you've got to think about, OK, does that mean those headers count as one column or two, one row or two. There's no box around this thing. Well, human experts who have applied a consistent rubric annotate the document this way. And so our formal opinion about this document is that there are 6 rows and there are 7 columns. But it is tricky. And you can see that Textract got fooled by this until now. You can see the information is laid out in columns, but then the headers get split. And there's some extra columns as well. But now we get it right. With the new model that's launching next week, Textract is a lot more robust to merged cells, to formatting that can create extra columns, extra rows. All that stuff goes away. And this works in more documents, more types of documents, more conditions under which documents were captured. Let's do one more. It's a little bit more complex. This is the document we looked at before, and it's kind of a mess. There are actually 3 tables here. One at the bottom left you could call 7 o'clock, one at 5 o'clock, and one at 2 o'clock. And Textract used to get 2 of the 3. And with our new model that's launching just next week, Textract automatically, without any configuration, any templates, extracts lots more information off this page. So it's really exciting. Next, we're going to talk about augmented artificial intelligence, A2I. And some of you may have seen this announcement yesterday in our CEO's keynote. A2I lets you combine artificial intelligence with the nuance of human judgment. It lets you specify that under certain conditions, the inference that comes out of a service like Textract, including Textract, the decision that needs to get made on top of it is so sensitive that we're going to set business conditions under which human beings should take a second review. And the way this works is you're going to define under which conditions that human review is going to happen. And then every time you call Textract or another supported service, and today we support Textract and Recognition and SageMaker, and the list is going to expand. Every time you call Textract, those business rules will get applied, and human review is going to happen. And so you're going to get the nuance of human judgment together with the power of artificial intelligence. So for example, you can say, Textract, I want you to send all documents for human review if you detect a form field with a confidence score below, say, 90%. Because maybe it's really important to make sure we're reading this document right, and if Textract isn't sure based on the vagaries of this document or how it was captured, how it was scanned, well, then a human being can take another look. Along similar lines, you might say that I know a priori this document has a certain type of information that's on it. And I know that if you didn't find a field called adjusted gross income, something is wrong. Either the document is wrong or Textract is wrong. So send that to a human. You could even take a random sample, roll the dice every time, and send 10% of your documents for human review. So by way of some customer feedback, here's the UK National Health Service that, far from extending artificial intelligence by making it more nuanced, in fact, the ability to use human review unblocks their ability to use AI. NHS is making medical decisions about whether to dispense pharmaceuticals and reimburse pharmacists for them. And there are regulatory reasons and medical reasons why it's important to have human judgment in that process. And whereas they've wanted in the past to use AI to offer better patient care, they couldn't do that without a human backstop. And A2I squares that circle for NHS, because all of a sudden they can expedite how fast the processing gets done and set a threshold based on confidence score, based on important fields, based on random sampling, that shows the human beings are still going to be able to do that backstop and bring that nuance into the process. So in this case, the human review actually unlocks the power of A2I for this customer and for this customer's end stakeholders. More from the kitchen with TextRact. We launched HIPAA eligibility just in October, which means that healthcare sensitive workloads can take advantage of TextRact 2. Thrilled to see the early uptake in that. We're expanding the size of the files you can send through TextRact. We have two APIs. One is synchronous and one is asynchronous. And in the sync API until today, you could only send 1 megabyte files. Now they're 10. Bigger files, higher resolution. In our async API, you can send even bigger files. You can send 500 megabyte files through to our async API. More information to unlock. We're expanding the regional footprint of TextRact 2. Just next week, you're going to see us launching in Sydney and in our San Francisco region. So really excited about what's coming, what has come recently from the kitchen, what is coming in the near future from TextRact, and you're going to see this pace continue. So let's dig in a little bit more. One of the things that we've learned is as customers move from initial hello world and testing to development into production, a couple of common questions come up. And it's worth spending some time on them because it maybe can help other customers be successful with TextRact even faster. Let's spend some time talking about the output of TextRact. Now, TextRact is an API. And as a result, from your document, which you upload, you get a JSON. And gosh, there's a lot of information. Here's a page from an Amazon SEC filing. This is our filing to the Securities Exchange Commission as part of our responsibility as a public company. And there's a lot to a human being to read it. But TextRact finds more. TextRact finds more than 22,000 lines of JSON from this single page. And naively, you might want to know, in this first table, what is the age of Jeff Bezos, who's our CEO. The number 4 is in there. That's one of our lines. So why do we have the rest of that? Well, let's talk about it. Here are those, what did I say? Did I say 32 lines? There are 32 lines. Here they are again. And what you see are 3 types of information. You do see the answer to the question. That number 54 is in there. That's one of our lines. You also see a confidence score, which expresses how confident is TextRact that the answer is right, that that is actually what's on the page. And you can use that to make business decisions about, do I trust this number? Do I send it to a human being? Do I do something else? We'll spend a lot more time talking about confidence scores. And there is structure. And remember, as I said before, so much of the information in document pages comes from the way the structure is represented. How are the words and numbers positioned relative to one another and positioned on the page? So this includes the type of information. Is this a word? Is this a table cell? This includes the positioning on the page and its geometry. And it includes its relationships. Relationships. If I focus on the last line of the JSON, here's a unique identifier for this component, this block. And what you'll find is that TextRact also expresses the relationships between information as these blocks. There's a hierarchy of the types of blocks that you're going to find, and they get expressed. So for text type information, there's a hierarchy of page to line to word. And for tabular information, there is page to table to cell to word. Forms have key value pairs and words again. And each of these have content, and they have geometry and structure, and they have confidence scores. And so depending on your application, there's actually quite a rich set of information that you can find and use for decision making based on that information. There's also a simpler way to do it. You can use the scripts that we've provided to get access to a raw text file that dumps out the information without any of the other decoration. You can use our script to get access to a CSV file that turns a table or key value pairs into a file you can open in Excel and manipulate directly. And you can even use the scripts that we offer to create what's called a searchable PDF. A searchable PDF has the image of the document as its background, but also has an invisible layer that is searchable by a human being. You can hit Control F, Command F, you can search through it, and the text will be overlaid at exactly the same place as fits the underlying image. And with TextRack, you can generate those too. And the script is available for download. You can hit the QR code. We'll post all this as well. So let's talk about confidence scores now. First, we'll talk about how confidence scores are generated, then we'll talk about how to use them. The way we generate confidence scores is by combining mathematically bottoms up and tops down estimates of how accurate we are at, for example, the character level and the word level. For each level of the hierarchy that you saw before, TextRack has distinct machine learning models. And we triangulate a single confidence score for each level of the tree that you can use. So that's where it comes from, but how do I use it? The idea is that you actually can, as a developer, as a customer, make a decision about the operating point that you want to select. In machine learning, there is a trade-off to be had between what's called precision and recall. Recall tells me how much of the information did I find in this piece of media, this document, this image, this video. Precision tells me how right was I? Were there false positives, false negatives? And you'd like to have perfect precision and recall, and in practice, there's a trade-off. So the TextRack confidence scores let you do that. You can choose higher precision and lower recall to get less noise and higher confidence information. Confidence, right? You can also choose higher recall at the expense of precision and get more content at the expense of greater noise. And what we've done to simplify all this is we've collapsed this XY axis into a single number, which is the confidence score. Higher confidence means less noise, less content detected. Lower confidence means there's more content and more noise. And that's how you can think about it. There's no right or wrong answer. It's about what is the appropriate posture for your application to take. You're going to find there's two types of confidence scores as well within TextRack. There's confidence scores for the content, which describe, was it recognized accurately? Was it the number 54? Or is Jeff Bezos actually 55 years old? And that's distinct from the structural confidence scores. Was this table detected accurately? Are these keys and values properly associated to one another? We give you all that granularity so that you can set independent thresholds if you want to. Or again, you can use our scripts and abstract all of that away. So when you think about what is Textract, let's review where we are. Textract is machine learning that reads documents as a person does. It has text and tables and forms. We have a pretty rapid pace of innovation. And the devil's in the details of how you actually put it to work. So I can't think of a better way to demonstrate how we put it to work than hearing from one of our sophisticated customers who's done lots and lots of work with Textract so far. With that, I'd like to invite Siddharth Ram, who's a fellow at Intuit, who can talk about some of the work that Intuit has done with Textract and the results that they've seen so far. Come on up, Sid.
Great. It's not cooperating, sorry. Well, thank you. Right, hello everyone, and thank you, John. My name is Siddharth Ram, and I'm a fellow at Intuit. And I'm going to be telling you a little bit about how we have been working with the Textract team and what we have learned from Textract over the past few months of actually testing it and actually putting it in front of our customers and what business problems we are solving. So let me just set a little bit about the agenda of what we're going to be talking about. I'll tell you a little bit about Intuit, what problems we are trying to solve for our customers, who our customers are, what we are doing prior in order to solve the problem we had, and where Textract fits in, and where we are going in the future. So Intuit's mission is to power prosperity around the world. And this is a mission we take very seriously. When you look at our product portfolio, TurboTax, Mint, and QuickBooks, I'm sure there are at least a few of you who are users of this. Yes? Yay. So what is TurboTax? TurboTax's job is basically to simplify the way you do your taxes at the end of the year and help you make easy decisions about taxes, whether you choose to do it yourself or you choose to do it assisted with the help of an expert who are supported on our platform. QuickBooks is all about small business. Small businesses are the lifeline of our economy. And we make it easy for small businesses to stay on top of our finances, let it be how they receive and send payments, let it be understanding their business, let it be staying compliant, or let it be dealing with their employees. And that's the part I'm actually going to focus on. And finally, we have Mint. Mint is for personal finances. I'm sure some of you are familiar with Mint. We make it easy for you to understand how you're doing in your personal finances, what your money is coming in, what money is flowing out, saving for a target or budgeting, and so on. So we serve consumers, small businesses, and self-employed. And in everything we do, we are always putting these customers in the middle of all we do. And just by way of accolades, Fortune's most admired companies since 2004 running, Fortune 100 Best, World's Most Innovative Companies, and 2019 Companies Best Position for Breakout Growth. A little bit of an advertisement. We're always hiring, so I thought this doesn't hurt. So where does this presentation fit in? Well, when you think about the work we do, data science is a part of every single thing we do at Intuit. It's really fundamental to everything you do. When you think about taxes, taxes are super complex, actually. It varies by state. Even some counties have got their own regulation, and it can get incredibly complicated, and we use AI in very specialized way to help taxes, especially through the use of knowledge engines. That's one of the areas where we spend a lot of time on the tax side. We do a lot of things with personalization, A/B testing, security. Everything we do has got AI. And of course, document processing is also a place in which we apply our AI skills. And the problem, though, we had is things were not scaling very well. When you look at the amount of documents we have to process and the variety of documents we had, there are different ways. John actually referred to different ways of doing it. You can have humans doing it. You can have the older style OCRs actually doing that for you. Some of these things weren't really scaling. And to kind of explain the problem to you, I'd like to zoom in on a particular product we had where we started experimenting with, is there a better way of doing things? So that particular product is payroll. So imagine that you're a small business, and as a small business, you have employees. And when you have employees, you have to pay the employees. And while you're paying the employees, you need to make sure you're paying them correctly and taking care of all the compliance regulations that exist in the payroll domain. That is, you need to make sure that all the deductions are done properly, and that's something our payroll business actually takes care of it for you through a product called Full Service Payroll. So if you're a Full Service Payroll customer, we tell you, hey, we'll take care of things. You have any paperwork, you don't know how to take care of something, we'll actually, you tell us how many hours, for example, your employees have worked, and we'll actually take care of ensuring that the right amount is being paid to your employees, and the right amount is being sent to your state and federal taxes so that the right deductions are being made. And by the way, if something goes wrong, it's on us, not on you. We'll make sure that any penalties or anything that happens, we'll take care of it. So obviously, there is a real importance in ensuring that what we are doing is correct. Now, the problem that happens that we are trying to solve is something like this. A customer gets a letter like this from the government saying, hey, and this particular one is from the state of California, the Employment Development Corporation, which is basically saying that your unemployment insurance rate is so much. Well, small businesses typically, A, not sure what they should do with it, and B, don't really want to deal with it. So what do? They just turn around and say, hey, you're taking care of payroll for me. Here's this piece of paper I received for the government. Do something with it for us. And so the way they do it is either our preferred way, which is you log into QuickBooks and you upload a document and we take care of it. Or alternately, there are still customers who actually send us email, even send us faxes, and we need to take care of these documents, right? So this is one example of a document that we deal with. But as you start looking at the bigger picture looks something like this. You know, if you multiply the number of customers we have by the number of products we have and the number of forms you have to deal with, and you have to remember, just in the payroll domain, there are forms that counties have forms. You know, in some cases, cities have forms. State governments have forms. Federal governments have forms. There is no structure associated with any of them. It's actually a letter that comes in, which is not meant for machine readability. It's meant for human consumption. So what we have to do is take all these documents. And this is, by the way, the 60 million number that I've referred to over here, that's not even the full picture. That's a subset of the documents that we are trying to deal with. And we are trying to get to a place where we are applying some of these old school techniques like OCR, which have got problems because, for example, every time you have a new kind of document or a state changes its document, well, you kind of need to go back to a drawing board and kind of think about, OK, how are we going to do OCR on this? Or we apply human intelligence, which obviously works incredibly well, but is not very scalable. So we are trying to deal with massive quantities of documents which needs to be processed. And so we started wondering, OK, how, you know, given the rate at which these documents are growing, which is also, of course, a reflection of how our business is doing, how do we get to a point where we can actually do it a whole lot better than we are doing it today? So, you know, like I mentioned, Intuit obviously has got a really strong presence in machine learning, but the bandwidth for almost any company and how much you can do with machine learning is limited because there are literally hundreds of problems we are trying to solve, right? So if you really want to scale, the way we think about it is always think about converting things from a machine learning problem into an engineering problem. Because engineering is relatively easy. You know, we have got really sharp engineers. Of course, we have sharp data scientists also. But engineering solutions, we can turn around really, really quickly. Right? So what do I mean by converting to an engineering problem? So if there is a service, for example, Textract, which all I care about is there is an API, I can push a document to that service, and it will give me a certain level of confidence, which will assure me that the problem has been solved, that the document has been understood, I can move on. right? So of course, no solution like this is really going to get 100% right. So we're generally thinking about it in terms of the Pareto principle. Is there a way I can solve 80% of the problems that we have, using something like TextRact off the shelf? And then for the remainder of the 20%, I'm going to either do handcrafted, data science / machine learning algorithms, because those are really hard problems and require devoted times, or potentially use like the human-in-the-loop solutions that John had referred to earlier, right? But solving 80% of the problems would take us a long way. So with that, we started thinking about, OK, let's go out and let's do a review of what is happening in this field and who are the wheel makers in this field that we need to kind of go and look at and see how they can help solve our problems. So we pretty much looked at all the solutions in the field. We narrowed down to a couple of products that we wanted to try out deeply, and we selected TextRact based on a POC that we did with a couple of tools, because we actually liked what TextRact was actually doing and how rapidly actually it was improving. Both of these were really attractive to us. So to explain how we went about actually doing our analysis and understanding whether TextRact was the right tool for us, this is how we approached it. So the first thing we did was said, we're going to take a form, and this is the actual form that we selected. This is a sample, of course. So this is called a Form 941, which comes in from the IRS, right? And this particular form says that, hey, you better make sure that your estimated taxes are paid up to the government in time, right? And on the top, you see what is circled in there is basically the place where we have got the key information. We need to, when a document like this comes in, we want to be able to identify what this document was and what some key attributes that we need from it, which is in the table on the right, which includes the taxpayer ID, the notice date, the tax period. Those are some of the key things that we need in order to take a document like this and convert it into an action for our software further downstream, right? So again, keep in mind that these kinds of documents come in through lots of different sources. It could be coming in via email. It could be coming in via fax. A lot of these actually come in via documents which have just been uploaded directly into our product. There are some customers, who actually still insist on sending us snail mail. So we actually get some of these actually coming in snail mail, and we actually have a team which takes this and actually processes it. Because for some customers, changing old habits is actually very difficult, and we're not going to force you to do something that you don't feel comfortable with. So given that we have got all these different ways in which documents come in, we actually had to go in and understand, so how often will TextRact actually be successful in extracting the content we are interested in? So what we did with this is we basically said we are going to play some games with TextRact and see how often we can fool it. So here's examples of what we did. We took the form. The second image basically shows a trifold. We have actually folded it, which is very common. If you're getting a letter in the mail, it's quite likely that it's going to be folded up in the envelope. The third shows, we actually deliberately introduced some shadows into it, right? And then took a photograph of it, and then asked TextRact to actually make sense of it. The fourth one is trifolded as well as kind of crooked, so. And then we did all these games. The second from the bottom, on the bottom there is interesting. We actually crumpled it up. Someone might do that, throw it in trash, and then realize, oh, I made a mistake. I actually need this. So took a photograph of that crumpled up thing. And so blurring, there are all kinds of things that we did it. Here are some more examples. We actually put a glass of water on top of it so that there are water stains on it. There's also another one with coffee stains on it, but the coffee stains one is not going to work because the letters were obscured by it, so I didn't even bother putting it up here. So these were all the different tests that we ran to try to figure out how well can TextRact do what we really needed to do. And this was very deliberately to kind of try to figure out, when will it break? Kind of reminds me of Calvin and Hobbes. I don't know if there are Calvin and Hobbes fans over here. Calvin asked his dad, hey, how do you figure out, bridge, no more than 10 tons was what the sign on the bridge said. He asked his dad, how do they figure it out? They say, oh, well, they drive trucks bigger and bigger till the bridge breaks, and then you repair the bridge again. I don't know why it reminded me of that, but it's kind of like that. We were trying to take stuff through TextRact till it broke down and said, no, we can't deal with this any longer. So here are some of the results. And we did lots of different iterations. And what we found out was you will see that number 7, which was the crumpling, number 8, which was blurring, and number 10, which was crumpled as well as deliberately brightened to simulate an overexposure, were the 3 areas in which this TextRact actually could not do a very good job. And so the x-axis on the graph on the right-hand side is basically the confidence scores. So the maximum you can get is a 1. The gray line, I will go into explaining what that is, and then you can see what the results of the confidence scores were. So John kind of explained the precision recall game, and for us, engineering, it was really simple to say, we're going to focus on just the confidence score. Right, so those are the results we got. So over an extended set of tests that we ran, here's basically what our takeaway was. So the box plot on the left-hand side is showing us incorrect results, and the box plot on the right-hand side is correct results. And what this basically says is, for everything that we said, thumbs up, TextRact has done the right thing. The confidence score generally averaged out, or the median was about 95, 96 or so. And when it failed, it was below 0.8, right? So we use this information to basically say that, hey, actually, if the confidence score returned is less than 90%, we are just going to say, forget it, we don't trust it. If it's above 90%, we are going to say it's good, right? So that was basically our summary of what TextRact was. And as you see on the previous charts, there were like about 3 out of 10 which failed. Now, again, you have to remember this was highly contrived. We were deliberately trying to introduce errors into the system and really understand, what the capabilities of TextRact are. In reality, it's actually better than 80% of the time TextRact can do the job for us, because these error conditions that we are describing don't happen all that often. So that was basically our point at which we said, look, this is looking pretty darn good, right? So once we did that, we said, OK, we are going to figure out how to put this in production and put this in front of our customers. So how did we actually do that? So this is what we did. This is kind of our system design. So what happens is a customer uploads a document. And again, there are lots of ways in customers upload documents. And once the document has been uploaded, it actually goes into a document service. There's a document service we have built on top of S3. So the document goes into this document service. And then I should quickly mention, all this is, our stack looks like microservices. Everything is a microservice. We use Kubernetes for our deployment. We are actually, pretty active in the Kubernetes open source area. If you haven't seen some of our talks on Kubernetes, you should, including open sourcing something called Argo CD and workflows, React, the Java stack, and we use Kafka as our bus. So once a document has been uploaded, there's basically a notification which goes out, which gets picked up by this document comprehension service. And what this document comprehension service does, it says, OK, first of all, I'm going to send it to TextRact and wait to hear back from TextRact and see what TextRact has to say. If we get a confidence better than 90%, we are going to declare it a victory, store the results, and call it a day, right? However, if the confidence score is less than 90%, we are going to flag it. It's going to get picked up by our document understanding platform, which is our in-house document specialization. We have our own algorithms for doing difficult cases like we had discussed. And that document understanding platform is going to come back. And we get a certain retrieval rate from it, that is certain things that TextRact could not deal with, we are actually able to deal with, because we are narrowing down on very, very specific use cases that we want to address. There is still a certain percentage of document that is cannot be dealt with, like those crumpling and the watermark things we talked about is just really, really hard. And so we have a human in the loop solution for that. So basically, that's our last resort. If nothing works, it goes to the human in the loop. And once we get the results of that, and that gets stored back in our document repository. So that's basically the process that is followed in what we are doing. And this has actually worked pretty well for us. It'll shortly be in large-scale production. It's in small-scale production right now, while we are making sure that all the corner cases are dealt with. And one of the corner cases we do need to deal with is when we are talking about 90% confidence, there is still, and we are declaring victory, there are still a certain number of cases where it would actually have problems. So how do we deal with that? And how do we do quality control on those cases? Those are things we need to think through very carefully about how we address that. And our short answer for that at this point is once the work is actually, so the workflow that is followed right now is humans are very deeply involved in transcription of the forms which come in. And from that, we're switching it into the transcription work is done, just have a look at it, make sure it looks good, and then click on a button and you're done with it. So that in itself is a huge advantage. At some point, we want to get to a point where we actually don't need the human approval because we feel really confident. We are not there at this point. Cool. So with that, here are some of our key takeaways. Number one, engineering problems are simpler to solve than data science problems, right? So if you can convert something into an engineering problem, life is just better, I think. You just tend to move faster and help your customers better. So the 80-20 principle is important. We are not looking for a perfect solution. We are quite happy with getting most of the way there and understanding there are going to be complexities around the way. So we are really trying to make the simple easy and the difficult possible. And the real value that we get with Textract is it allows us to focusing on, on those 80% of the use cases, moving really, really quickly and helping our customers, by actually being very accurate with and very quick, efficient with the work we are doing. Rather than having our data scientists focus on all these problems, we are actually getting them to focus on the really hard problems that we want to solve. And basically, if we can do some of this work by leveraging the Textract team, we absolutely want to do that. That's actually a more cost-efficient or time-efficient way for us to solve the problem. The other thing which is of great value to us is the speed at which, honestly, the Textract team has moved. We have worked very closely with them. Early on, we weren't completely comfortable with the way the confidence scores were being calculated, and this is something we worked pretty closely with them, and we are incredibly happy. In fact, the turnaround for some of those changes we asked was in days, in single-digit days. And the last thing I'd tell you is what was pretty amazing about this whole thing was we actually had a couple of interns actually do most of this work, which was pretty astounding, to see that you can take this problem which earlier required the attention of significantly experienced data scientists working for long periods of time to solve this problem, and kind of we're able to hand it to a couple of interns and say, hey, can you take care of this problem for us? And obviously, we helped them, and I was quite involved with it. But realistically, most of the work was done by interns, and they actually worked very closely with the Textract team to get to the outcomes that I've kind of shared with you. So with that, thank you. In particular, Idan Sneh was an intern from the University of Washington, and Neville from CMU. And there are a couple of folks at Intuit, Sricharan and Jennifer, who actually work closely with us. And that's the presentation. Thank you.
Thank you, Sid. There's a wrap up, and then we'll do questions. All right. Thank you, Sid. So that's pretty cool. I will say they were smart interns, maybe not any intern. But no, in seriousness, it's really encouraging and exciting to see the work that our customers, such as Intuit, are doing. I take two messages from the story. The first is that converting, as Sid says, science to engineering problems is good, but even better is being able to focus the resources of top caliber scientists, such as you would find at Intuit. And so whatever level of capability that you have in your own organization, it is always better to focus that and concentrate it as tightly as you possibly can. And use Amazon as your science, as your engineering extension to get undifferentiated heavy lifting out of the way. So that's one. The second is to highlight a point that Sid made, the sensitivity of financial decisions relating to people's tax documents and tax filings is so great that human attention is often important. And that's okay. It doesn't mean that AI isn't important too. It just means that these things can actually work together. And by having a thought-through strategy of how human in the loop is going to be, whether it's with something that already exists so that you build yourself, or with something such as Amazon Augmented Intelligence, you can actually accelerate how fast you can adopt AI on behalf of your own customers. So really exciting from Intuit. Thank you, Sid. Just a couple of key points as we wrap up. Documents are hard. They're important, but they're hard, right? And it's because of the types of structure and the way the data is laid out. It's because of massive and unpredictable variation in the types of documents. Did you guys know that W-2s are not always the same? In fact, they're different all the time. And because of distortion in the way that they're captured. And so if you want to read content at scale from documents and make important and high-value decisions out of it, you're going to need something better than the traditional solutions that have been either human-driven or software-driven or template-driven. And that's why we built Textract. Textract is designed to use computer vision and machine learning to read documents as people do, to retrieve text and tables and forms, and retain not just the words and the numbers, but also the structure of the data. So that's Textract, and you can hit an API and you can get consistent output that you can then take programmatic action on or pass to a human being. When you do this, you're going to get really accurate output. You don't have to create any templates, do any configuration. You're going to reduce how much manual effort, translate science problems to engineering problems, as Sid said, lower your cost, and do this all without machine learning experience. And the pace of innovation is really exciting. Just some of the things that we spoke about today. We have a brand new tables model launching next week. We have integration with A2I, augmented artificial intelligence. We launched support for HIPAA, region expansion, larger file sizes, and there's lots more coming from the kitchen. You can check out our code samples page, by the way. That QR code, that link, points you to it. We publish new stuff there all the time. And most importantly of all, the best way to get a view of what Textract is for is to try it. I can't stress enough how easy that is. If you log into the console, you don't just need no machine learning experience. You need no development experience. You literally drag and drop your document and click download results, and you can drop it into Excel, drop it into a Word editor, or you can play with the JSON. Drag and drop, and you can try it yourself. That's Textract. Thank you very much. Thank you for your time.